All right, welcome back to completing the square and writing a quadratic function in vertex form. I'm hoping the volume on this is actually working and my tablet is not muted as it was for the last few videos. So I'm hoping this is the last time I have to record this one. All right, so let's take a look at what we've learned so far about the function, the quadratic function. Now we've learned that there's a general quadratic function. F of x is ax squared plus bx plus c, where a, b, and c could be any number. And we called them parameters. So, and that we can find out different things from different forms of this particular function. So we can find the y-intercept from this form, but if we write it in this kind of form, right, something squared plus something, then we'll also be able to tell some shifts. All right, we'll be able to know some shifts, whether it's shifted up or down, whether it's shifted left or right. So we'd be able to use these values in here to figure out where this function is located. Well, that's great. So our goal, okay, is to be able to produce functions in that form when we actually have it in standard form. Now, let's see how we might be able to use our Algeblocks to rewrite functions in that form. First, just like with multiplication, we needed to figure out what do things look like when they are in that form on Algeblocks. So let's take a look at two of them, and I'll leave you the other two to play with. So for example, if we have x plus 3 all squared plus 6. So if we're going to model this is a square. So it's a factor multiplied by itself. So this is going to look like a square on the Algeblocks. And this is going to look like loose units, those green little cubes. So let's see what we can do with a square. The x plus 3, okay, and x plus 3 will look like this. So we can create the square that is x plus 3 all squared. Okay, and lining everything up, we will see the same structure that we saw before. We will see that we have an x squared. We will have two groups of x's, one vertical, one horizontal, and we will have the units. Okay, and that will actually be the square aspect. But then we also have this plus 6. Well, the plus 6 are loose. They're in addition to the square, so there will be some loose pieces. Okay, so it looks like we have a square with that as a side, with a factor as a side, and plus 6. Let's see if here, in the second problem, we'll also see a square with p minus 2 as the side, right, and 5 loose units. So let's see what we have. P minus 2. And so I'm modeling p minus 2. So the square part should come from us multiplying those p minus 2's. Notice that we have the p squared, the vertical p's, the horizontal p's, and our 1's, right? And that's the square that has a p minus 2 side, both vertical and horizontal. And then we have some loose pieces, 5 loose pieces. Okay. Notice the structure within the square is still the same. We have the x squareds that are kitty corner to the units, and then we have the horizontal and the vertical rods that are also kitty corner to each other. So make sure that you complete the B and the D, questions B and D, and see what kind of patterns you notice. What do these squares look like when we're in Algeblocks? You can skip the E and F, but do fill out this, your observations here. What do all the mats, which include perfect squares, look like? What do they have in common?